Basically, I'll be talking more on the sewage treatment part of the water circuit. So a brief overview about Forbes Marshall. Forbes Marshall, actually, it's a 75 years old organization having 5 factories, 4 in India and 1 in UK. So 3 of them are in Pune. We have 40,000 plus square meters of space, having around 1,400 plus engineers who are working in the field. And 300 of them are in the field from sales and service. And then we have around 300 plus products having all certifications which are required for running a factory. In a typical water circuit, you have water coming from either from the surface or from borewell. It actually goes, if it's a seawater, it goes to a desalination plant, or if it's a surface water or a tube well water or borewell water, it goes for treatment to water treatment plant. Then it goes to distribution, and from distribution it is consumed either in the factories or it goes to the households. And then after, effluent is generated from the factories and sewage is from the households, and then it goes back into the river water or into the earth. Now, in all these areas, we from Forbes Marshall and from and most of the technology companies have now instruments, online instruments, which can monitor quality and quantity of water. Quality means when you have surface water or if you have borewell water, you need to check the turbidity. You want to check other parameters which are required to be before the water is given to the water treatment plant. And after the water is treated, you have to maintain the free chlorine, then pH, total dissolved solids, and stuff like that. And likewise for sewage treatment plant, you have various parameters before the water is, basically goes into the before the water is put back into the river. So like you have, chromium, solids like chromium, then ammonia, total nitrogen, total phosphorus. So there are online analyzers available for all those parameters, apart from BOD, COD, total suspended solids. As far as sewage, this we just took from some of the Government of India sites. We have total sewage generation of around 62,000 MLD in the country, out of which only 23,000 is what is treated. Rest is all untreated, and just it is either given back to the earth or it is drained in the running water or rivers. In metropolitan cities, 51% sewage is getting treated with available installed capacity, and 70% of surface water in India is unfit for consumption. So, coming back to availability of water.
Just for clarity, I think this is only Class A cities, not the entire country.
Metropolitan, that's right, metropolitan. Scientific analysis of water indicates that we have organic and bacterial contamination, which is pretty severe in water, which is the main cause of lessening the quantity of water. So even if water is available, it is not available for drinking or for household purposes. So proper treatment of water is important. So that's what my presentation is about. And the challenges which we have for these sewage treatment plants in India in particular, we have high treatment costs, high energy consumption. It takes long time. These shutdown losses are higher, and huge maintenance costs. So being a technology suppliers, we have tried to, we have sat with the people who are running these sewage treatment plants, try to understand how they are running. We have gone to old generation sewage treatment plants. We have now gone to the ones which have come up recently. And based on that, we have some solutions. So what we observed is, earlier we had, a typical sewage treatment plant will have a mechanical, electronics, and some basic instrumentation. Instrumentation was limited to only lab instruments as far as sewage was concerned. After the treatment, the water was analyzed in the lab, and that data was kept to make sure that in the further treatments there are some improvements which are taken care of. Now with the availability of, with the advent of online instruments, we now have a lot of information whereby we can take proactive steps so that we can overcome those challenges which we just talked. So we have now softwares, we have data which doesn't lie, as Mr. Pradhan was telling in the beginning. So data actually empowers us a lot to take care of the challenges which we face in the sewage treatment. Now, actually, I'll talk about these 4 quadrants. What we have in the first is this maintain. Here, it's a basic sewage treatment plant where you will have monitoring of the parameters. the, for example, pH or for example, dissolved oxygen, it will be maintained, and to some degree it will be also be controlled, but this control will be based on the technology. However, we will not be having any view, like human will be blind to what is going on inside the sewage treatment plant. Now to improve upon that, we move on to the next, where we involve people. So here, the technology will now give you some alerts. They will start giving you some diagnostics. So based on those diagnostics, the people will start improving upon those processes. Like earlier, if there is suppose a PID loop, it will keep functioning, but it will tell you how the loop has actually performed, whether your process value was close to your set value or it was far away from that. So then this basically will actually improve a bit from what we were doing with mere technology. Now to even add on to that, we have now, for further, we go to Excel. Here, we have benchmarks for all our motors, for all our equipments which we have, that this is how they should be performing. If they are not performing in line to that, then this will generate some predictive tools by way of which they will also start telling that this is what is exactly to be done to run it more efficiently. Then this will also be done by people only. Only thing is people will be more equipped, and they will be more knowledgeable to take care of the needs which are to be carried out to run the system more efficiently. Then putting all these three together, we have now an automatic control system that networks with the remote. So we can have somebody sitting in remote, and he can start devising ways to run the systems more efficiently. So we'll have some people. It will be coupled with people and technology both. So then once this is done, we can address each and every small package inside a sewage treatment plant. Like you have aeration control, where you will have a DO, dissolved oxygen, which will be completely online, and it will also basically in a control loop, it will also the drive which is running with the aeration pumps which are running continuously. So those will be regulated based on the exact dissolved oxygen level which you will get. Likewise, for MLSS, you will maintain the level. Likewise, for backwash cycle, when it is required, it should not be time-based. This is a typical architecture. Actually, sir, nowadays technologies are available to pull the data. Like sir was telling that how do we get the data you can monitor the flow, but how do we get the flow to the control room? Nowadays, there are technologies available by way of which you can get the data. We have small remote terminal units or small devices which can be mounted right at the device, and those can be powered with battery. You need not have a AC powered, and they can pull the data, and those data can then be fetched on to web, and from web you can see it anywhere. So the technology is available, and it is running at a lot of places, especially in the water distribution sectors. Of course, not in these sectors as of now, but in water distribution, we have a lot of success stories to talk about that. So this is a typical network where you will have sensors coming onto a control system, which will be inside a sewage treatment plant, and then you will have trends, patterns, diagnostics, alarms, alerts. And then this, you can transmit it on a local area network to the entire plant. Then once this is done, you can generate dashboards. Like it can give you system health, it can give you production health, it can give you effectiveness. What was the plant uptime and sensor uptime? Because if you have sensors, the sensor, whether it is working perfectly or not. So there are diagnostics built inside the sensors also. Like in a pH sensor, pH sensor has generally a life of 1.5 to 2 years, depending upon the application. But it can go bad early also, or it can go a little longer also. So there are ways to measure whether pH sensor is working fine. Likewise for dissolved oxygen sensors, likewise for BOD, COD, and other sensors. So then you can also come to know about the production health. So this, we call it plant utilization sector. We borrowed this word from power sector now. So how much is the theoretical capacity, and how much did we actually treated? Then daily limits for the equipments. So have we gone through these limits, or we are well within those limits? Then driving the plant effectiveness factor. So source of efficiency, you will come to know efficiency of each and every equipment inside a sewage treatment plant. Then water quality parameters, like if you have analyzers for for BOD, COD, pH, total suspended solids, total nitrogen, total phosphorus, you will come to know what is the how effectively the plant has performed. So these are the, these are the live dashboards, like what is the effectivity of the plant as of now, what was the daily target, where we are on the target, like how is the system health, how is the sensor health for each and every. You can go and click and you can check which sensor health do you want to know. For example, this is shown for dissolved oxygen. So these are some of the benefits which we get, after we do some automation, which we call them smart STPs. We have automated plants, remote monitoring. We can enforce compliance, like earlier. Now the data from the sewage treatment plants in Haryana, it is actually going directly to the Central Pollution Control Board, and it also tells them whether your plant is running or not. It tells them what are the parameters, parameters within which you have to operate, and what are the exact parameters. And if the system is under maintenance, that also is highlighted. So very powerful dashboards have been built by Central Pollution Control Board and State Pollution Control Board. And then you can manage waste, fraud, you can reduce land requirement also. Then you can come to know about the energy and electrical savings by way of using dashboards. So, and then you have easy data access. So that's all from my side. Thank you.
I think very crisp presentation.